Okay, so in the practice questions you had lab exercise 12A and B. And in 12A you had this chart and you had to create a table from strongest oxidizing agent to weakest oxidizing agent. So you're going to look at which one of the oxidizing agents is the strongest, and that's going to be CD because it causes 3 of the 4 metals to react. Then next strongest should be V, 2 positive, and then BE 2 positive, and weakest should be RA. So now I just need to move it over here so I can create the table. So we said the first one should be CD. So it's going to be CD2 positive aqueous plus 2 electrons going to CD solid. Next up is this one, Valdineum, V2 positive. V2 positive aqueous plus 2 electrons going to V solid. Next one, beryllium, has just 1. So Be2 positive aqueous plus 2 electrons going to Be solid. And then the last one on the table was Ra, 2 positive plus 2 electrons going to Ra solid. Okay, so this one up here is the strongest oxidizing agent going down. This one over here is the strongest reducing agent going up. That's 12A. Now it gives you another chart for 12B, which has zinc, valdineum, cadmium, and lead in it. So again, you want to find which one's strongest, and it's lead because it's the one that causes 3 of the 4 to react. Next is cadmium, then zinc, and last is valdineum. Okay, so we're going to start, and I'm just going to do it, oh, maybe I'll do it down here. Okay, so we said it was lead was first, Pb2 positive aqueous, plus 2 electrons going to Pb solid. Then next was Cd, 2 positive aqueous, plus 2 electrons going to Cd solid. Third one was zinc, Zn2 positive aqueous, plus 2 electrons going to zinc-solid. And the last one, V2 positive aqueous, plus 2 electrons going to V. All right, so now, and then so this was the strongest oxidizing agent in this table going down to the weakest. Over here, strongest reducing agent going up to the weakest. All right, so now the question wants us to put these 3 tables together. Just trying to see if I can get all 3 of them in at once. Maybe I need to zoom out a little. Okay, so we need to come up with which one is the strongest overall. Well, on the top of this table, the first table that we did in the earlier video was silver going, and then copper, and then lead. Lead is on the top of our third table, so that means that silver and copper are stronger than anything in the third table. Okay, if we look at the second table, cadmium is on the top and it's under lead. So that means silver must be the strongest overall. So in our new combined table, silver positive aqueous plus 1 electron going to silver solid is the strongest overall oxidizing agent. And next to it is copper, Cu2 positive aqueous plus 2 electrons going to Cu solid. Okay, how do I know that? Because lead's underneath copper and lead's on the top of the third table, so lead can't be above them. And under lead on the third table is cadmium, which is on the top of the second table. So these silver and copper have to be the strongest, followed by lead. So Pb2 positive aqueous plus 2 electrons, electrons go to Pb solid. Okay, so now we've used 3 of the 4 on the first table. We look at zinc. which is the last one on the first table, it's under cadmium on the third table, which means cadmium must be next. So Cd2 positive aqueous plus 2 electrons goes to Cd2, Cd solid. All right, now, where does zinc go? Well, underneath Cd2 positive is V2 positive. And look in the second table, and look in the third table, V2 positive is under zinc. So zinc must go next. Cd2 positive aqueous plus 2 electrons going to zinc solid. Underneath zinc valdineum, it must come next, V2 positive aqueous plus 2 electrons, V solid. We've now used everything on the first table, everything on the third table, so the last two must be exactly the way they're listed on the second table. Beryllium plus 2 electrons going to beryllium solid, and then Ra2 positive aqueous plus 2 electrons going to Ra solid. We now have our full table. Up here will be the strongest oxidizing agent going down to the weakest one. And on the other side, which of course I didn't leave enough room for, strongest reducing agent is down here going up. Okay? And this is pretty cool, and this will become useful then. When we go to try to figure out, will something react, it'll be like, wow, I'm getting ahead of myself. This is homework. Stay tuned to today's videos where we'll figure out why this is useful.